Hello everyone. In today's video we are going to learn all the mensuration formulas. So the first question here is, what is mensuration? So mensuration is nothing but it is related to the measurement of all the geometric figures. Now measurement like the length, their parameter, their volumes, the surface area, the curved surface area or lateral surface area. So all these things are important in mensuration. So first of all, we'll look into the plane figures like square, rhombus, parallelogram, circle, and after that we'll move on to 3D figures or solid figures. Solid figures like cube, sphere, hemisphere, cylinder and all. We'll be discussing all the formulas related to volume, perimeter, then surface area, and also some of the properties that are related to all those figures. So let us start. So we'll start with the most common figure over here, which is a square. So you must have found that properties related to square are very common while solving geometry questions. Let us discuss a few properties. First one is all sides are equal. So you already know that all the sides of a square are equal. Next one is all interior angles are 90 degree. So this angle, this particular angle and this angle, all these are 90 degree. So we can also say that the sum of all interior angles is 360 degree. In fact, in every quadrilateral, the sum of all the interior angles will be 360 degree. Next property is diagonals are equal and intersect at 90 degree. So we can see here that diagonals are equal and they are intersecting at 90 degree. Next property is diagonals are perpendicular bisectors of each other. So they do intersect at 90 degree as well as they bisect each other. That means this particular diagonal, it will bisect this diagonal that is perpendicular to it. So this part will be equal to this part. Similarly, this diagonal will bisect the another diagonal and this part will be equal to this part. I hope this is understood. Then the next property is, this is basically the application of the properties for a two-dimensional object. For a given perimeter, the area increases with increasing symmetry. For example, among different triangles of a given perimeter, an equilateral triangle has the largest area. So assume that a question comes in which you have this triangle, you have this triangle and you have an equilateral triangle. You have been given the perimeter of all these triangles as 16, and if the question says that which triangle will have the maximum area, then we'll choose that figure which is most symmetrical over here. Symmetrical means all the parts of a particular figure that are facing each other, they must be exactly same. So here we can see that in an equilateral triangle, this side is equal to this side is equal to this side, all the three sides are equal. So this is the most symmetrical figure. While in this right angle triangle over here, we can see that this would not be equal to the hypotenuse, this would not be equal to the hypotenuse. So this is not as symmetrical as a equilateral triangle. Similarly, in this particular figure we have, for example, if we assume that the length of all these sides is different, so we can say that this is the most unsymmetrical or asymmetrical figure. So this will have the least area over here. So higher the symmetry for a given perimeter, its area will be the largest. After that, the area increases with increasing number of sides. That means for a given perimeter, the area of a square will be larger than that of an equilateral triangle. So this basically means that, for example, if we have two symmetrical figures now, we have an equilateral triangle and we have a square. Let us also assume that we also have a circle over here. All of them, they have perimeter 16. So for a given perimeter, the area increases with increasing number of sides. So perimeter of all these three figures is same, but we can say that a triangle has only 3 sides, square has 4 sides, circle has infinite number of sides. So this circle will have the maximum area when the perimeter is given. The area of a regular pentagon of a given perimeter will be larger than that of a square and so on. After that, if I include a regular pentagon over here, then I can say that, and if I assume that it also has perimeter 16, then area of this pentagon will be greater than the area of this square, but not greater than the area of this circle, because circle has infinite number of sides. Just after that we have another important point. Among different regular polygons of a given perimeter or circumference, a circle has the largest area. So using this rule you can easily solve a question in which you have been asked that there are 3-4 figures of different shapes, different sides, and you have been given a particular perimeter for all of them, and if you are asked that which one will have the maximum area, it will always be the circle. This is only about the plane figures. At last we have the formula for area and perimeter of a square, which are area of a square is side into side, you all are familiar with that, and perimeter is sum of all the sides, that means 4 into side because all sides are equal. So I hope everything related to a square is clear. Let's move on to the next plane figure now. We have a rectangle now. So rectangle is basically like a square, but a rectangle has length and breadth. This is the length of rectangle, this is the breadth. Again, all interior angles of a rectangle are 90 degree, but unlike square, it doesn't have length equal to breadth. In a square we have length equal to breadth. So first thing we can say about a rectangle is opposite sides are equal. That is applicable in squares as well. All interior angles are 90 degree. Diagonals are equal here also. Diagonals bisect each other but not at 90 degree. So we can see here that diagonals are bisecting each other but not at 90 degree. After that we have the area of a rectangle, which is length into breadth. Perimeter of a rectangle is 2 times the sum of length and breadth, because these two will be the length, these two will be the breadth. If we add them all, we get 2 times L plus B. Let's check the next figure now. Next figure that we have is a rhombus. So all the sides of a rhombus are equal. So all these sides, they will be equal. Area of a rhombus is given by half d1 cross d2, where d1 d2 are lengths of diagonals. So if diagonals are given, you can find out the area of rhombus using this formula. After that, area of rhombus is also given by a into sin x. So a is nothing but the side of rhombus. All are equal. Sin x is nothing but the included angle between these two sides. So you can take this angle as well, or even this angle. Measurement of both the angles will be equal, because we can see that this is x and this is 180 minus x. So if you find out sin x, it will be equal to sin 180 minus x. So it will always remain a into sin x, because sin x is equal to sin 180 minus x. After that, perimeter of a rhombus is 4 into side, because all sides are equal. Last one is diagonals are not equal and perpendicular bisectors of each other. So diagonals of a rhombus are not equal, but they are bisectors of each other and they bisect at 90 degree. So that's all about rhombus. Next one is triangle. So you are very familiar with a triangle. A triangle has 3 sides. The sum of interior angles of a triangle is 180 degree. There are many formulas to find out the area of a triangle. First one of them is half AB sin C. So half AB, A and B are the sides, adjacent sides. Sin C is nothing but the included angle between them, where AB are the lengths of the adjacent sides and C is the included angle. After that, area of a triangle can also be given by this formula, under root S minus A, S minus B, S minus C, which is nothing but the Heron's formula. This is also called the Heron's formula. This is useful when you have all the sides of a triangle, and this formula is useful when you have 2 sides and the included angle between them. Another formula to find out the area of a triangle is half base into height. So if you only know the length of the base, which is C over here, and if you are given the height of this triangle, you can easily find out the area using this formula. Last one is the perimeter, which is given by A plus B plus C. If all the sides of a triangle become equal, then it will be called an equilateral triangle. Then its area is given by root 3 by 4 into side square. This will be the formula of area of an equilateral triangle. Next figure is parallelogram. So basically in a parallelogram, opposite sides are equal. So here the sum of all interior angles is 360. So all the figures that are formed using 4 vertices, 1, 2, 3, 4, sum of interior angles of all such figures will be 360. After that, how to calculate area of a parallelogram? AB sin C. So AB are nothing but the adjacent sides and C is the included angle between them. After that, diagonals are not equal. So if this is one diagonal, we'll have another diagonal like this. They are not equal, but they are bisectors of each other. That means they bisect each other. So bisecting means dividing a particular line into two equal parts. This part will be equal to this part. Let's check the next geometrical shape. So now we have a circle with us. So questions related to circles are very common in all the MBA exams. So each and every property of a circle, all the formulas related to a circle must be clear to you. So basically this is the figure of a circle. You can see that in a circle we have a center, and the distance from the center of a circle to its boundary, it is called the radius. So area of a circle is given by pi r square. Perimeter or circumference of a circle is given by 2 pi r. Pi is nothing but a constant having value 22/7, or you can sometimes take it as 3.14 while calculation. We have one more point over here. Of all plane figures with a given perimeter, circle has the maximum area. So we have already discussed this in the case of a square, where I have told you some properties related to 2D figures. Now there are number of properties that are related to a circle, but since we are dealing only with mensuration, so we have just considered area and circumference over here. Now we have one more important point over here. This is regarding the 3D figures that have surface area and volume. So for a given surface area, the volume contained increases with increasing symmetry of the object. For instance, if we are to make objects of different shapes of same surface area, the volume will be maximum when it is made into a sphere. So again we are talking about symmetry over here. So this point is saying that, for example, if you have been given a cube, then you have been given a cuboid, then after that if you are given a hemisphere like this, you are given a cone, a cylinder, and at last you are given a sphere. This is a sphere. So which is the most symmetrical figure over here? Definitely it is the sphere. And if surface area of all these figures are same, because for a given surface area the volume contained increases with increasing symmetry. So which is the most symmetrical figure over here? It is the sphere. So sphere will have the maximum volume. So we can say that for a given surface area, sphere will have the maximum volume. At last, the corollary is that for a given volume, the surface area will be minimum when the object is a sphere. So this is another point. If you are given these 1, 2, 3, 4, 5, 6 figures, and you are given equal volume of all of them, and you are asked that which one will have the minimum surface area, then it will be the sphere. So sphere will have minimum surface area for a given volume, and it will have the maximum volume for a given surface area. I hope this point is clear. We have a trapezium with us. So trapezium is nothing but a quadrilateral that has only two of its sides parallel, two opposite sides parallel, and there will be two opposite non-parallel sides. So here this side and this side, they are parallel, this side and this side, they are non-parallel to each other. The formula to find out area of a trapezium is half into sum of parallel sides into height. So here we can write the area of this trapezium at half a plus c into h. There is one more very important formula related to trapezium. This can be applicable when you have to find out one of the diagonals or one of the measurement of the sides or length of one of the sides. So this is the sum of square of the diagonals of a trapezium is equal to the sum of squares of non-parallel sides and twice the product of parallel sides. If we square them and find out their sum, that will be equal to the sum of squares of non-parallel sides, that means b square plus d square, and the sum of 2 times the product of parallel sides. So 2ac. This is a very important rule. You must remember this. Now let us move on to solid figures. So the first one that we are going to discuss here is cylinder. Before this we were dealing only in 2 dimensions, length and breadth. Here we'll be dealing with a third dimension, which will be the height. So this is what a cylinder looks like. it has two circular bases, one is at the top, one is at the bottom, and it has a certain height. The circles that are at the base and top of a cylinder, they have a radius as well. So there are two important formulas that are related to a cylinder. First one of them is the curved surface area or the lateral surface area. These both are same. Now what is lateral surface area or curved surface area? We'll find out the area of the surface that is curved. That means this whole surface. We'll exclude the plane basis from here. So for that the formula is 2 pi r into h. Another important formula is total surface area, which I'm writing as TSA. Total surface area, that means we'll include the bases as well as the curved surface area. That means we'll include the whole area. So first of all we'll find out the curved surface area, which is 2 pi RH, and if I add the area of bases to these, we have two circular bases, 2 pi r square will be their area. So these are the two main formulas that are related to a cylinder. Another very important formula of a cylinder will be of its volume, which is pi r square h. Then there can be many type of questions that can be asked from cylinder, like if we cut out a cone from a cylinder, so it will be like this. Then there can be questions like if we have a hollow cylinder, that means we'll have this hole in between, and if the examiner asks you find out the volume of the material that was used to form this cylinder, then what will you do? You will subtract the volume of this smaller cylinder that is being formed at the middle from the volume of whole cylinder. So you will be given two radiuses over here. One of them will be the interior radius, which I am denoting as I. You will be given the outer radius. So if you are asked to find out the volume of this cylinder, which is hollow in between, what will you do? It will be equal to the volume of whole cylinder, which will be pi r square, because outer radius is O, so O square into h, minus from that you will subtract the volume of inner cylinder that is being formed. It will be equal to pi, inner radius is I square into h, because h is same for both. So that is how you have to find out the volume of a hollow cylinder. Let's look into the next solid figure we have. It is a cube that you are very familiar with. So basically this is the figure of a cube. A cube has 12 edges. It has 6 faces. So let me write it: 12 edges, 6 faces. All faces have equal area. All edges are equal. And a cube has 3 dimensions, which are length, breadth and height. All of them are equal. So length will be A, breadth will be A, and height will also be A. So first of all we'll have a volume of a cube. It will be equal to A into A into A. That means we'll multiply all the dimensions. It will be equal to A cube or side cube. All these are the edges of a cube. A cube has 8 vertices, 1 2 3 4 and 4 at the bottom. Then we have the formula for surface area of a cube. What will it be? We know that we have 6 faces. All of them are square faces and all of them have equal area. Area of one square face will be equal to side square, and we have 6 such faces, so 6 into side square. This will be the formula for surface area of a cube. I hope this is understood. Let's look into a cuboid now. So basically in a cuboid we have length, breadth and height. So this will be length, this will be breadth, this will be height. Volume of a cuboid will become length into breadth into height. A cuboid also has 6 faces. Opposite faces have equal area. So if I find out the area of 2 such faces having dimension b into h, so surface area of a cuboid becomes 2 times b into h, because we have 2 such faces. Then we have 2 faces having area b into l, so we'll add it 2 into l into b. Then we have 2 faces having dimensions l into h, so 2 times l into h. So if I take 2 common, lb plus bh plus hl, this becomes the surface area of a cuboid. Again, a cuboid also has 12 edges. It has 8 vertices. Let's look into next solid figure, which is a cone. So a cone has a top point and it has a base which is always considered to be circular. Since it is a circular base, it will also have a radius, and we have a cone, so a cone also has a height. Basically that height is from top point of the cone to the center of this circular base. This is the height of a cone. There is one more term in cones which is slant height, and questions are very common from this. Slant height is nothing but this height. This particular height is slant height. So what we can see here, we have a right angle triangle formed by the slant height, the radius and the height inside this cone. So we can apply Pythagoras theorem over here. Hypotenuse is slant height, L square will be equal to h square plus r square. This relation can be very useful in case of a cone. Then again for cone we have volume formula, which is nothing but 1/3 pi r square h. Then after that we have curved surface area or lateral surface area. We saw that in cube and cuboid we do not have any curved surface area, but in a cone we have a curved surface area, and it will be equal to, it is also called as lateral surface area sometimes, but both of them are same. It is equal to pi r into L. L is nothing but the slant height. So if you are given the radius and height of a cone, you can easily find out the slant height using this relation, and then you can put it into this formula. Then if I ask you the total surface area of a cone, you will add the area of base also to it. So pi r L will be the curved surface area plus area of base will be equal to pi r square. I hope cone is done. Next one is sphere. So sphere is nothing but a ball, a cricket ball that you must have seen, or a football. They can be considered as spheres. So this is the picture of a sphere over here. So basically a sphere also has a radius. We'll discuss the volume of a sphere over here, which is nothing but 4/3 pi r cube. A sphere also has surface area, and you can call it the curved surface area or lateral surface area. That is also equal to its total surface area, because in a sphere we only have curved surfaces all the time. So curved surface area or lateral surface area or total surface area all are same in case of a square, in case of a sphere, which is equal to 4 pi r square. So only these two formulas are useful in case of a sphere. Sometimes you might be asked questions related to hollow spheres. So you will be given an inner and outer radius, and you will have to find out the volume of the material that was used to form the sphere. Next one is hemisphere. So what is a hemisphere? If we cut a sphere from between, then we get two halves, and both of them are hemispheres. So in hemisphere we can see that we have two types of areas. One of them is curved surface area, and another is this plane surface area over here, its base. So if I ask you the curved surface area of a hemisphere, you will only find out the curved surface area, that is equal to 2 pi r square. If I ask you the total surface area of a hemisphere, it will be equal to 2 pi r square and the area of base, which is pi r square. So total surface area of a hemisphere is 3 pi r square. You just have to visualize the diagram in your mind, and then you can easily find out these formulas even without remembering them. Then after that we have the volume of a hemisphere, which is nothing but half of the volume of a sphere, which will be 2/3 pi r cube. If you are asked the volume of a hollow sphere, what you have to do, you will be given the inner radius, let me call it Ri. You will be given the outer radius, which you can call as Ro. If you are asked to find out the volume of a hollow sphere, it will be equal to 4/3 pi the volume of whole sphere, which will be equal to Ro cube. We'll consider the outer radius, minus 4/3 pi Ri cube. We'll remove this volume of sphere having inner radius. Inner radius is only till here, outer radius is till here. So I hope hemisphere is also done. Now the next important solid figure is a pyramid, and it is very important from that perspective. So basically a pyramid has a top point and it is formed by joining all the vertices of the base. If you join them at some point above the pyramid, it becomes the apex of a pyramid, which is the highest point of a pyramid, and this is called the base. So depending upon the type of base, we have different type of pyramids. We have square pyramids, that means square base. Rectangular pyramid, that means rectangular base. Octagonal pyramid means octagonal base. Hexagonal pyramid means hexagonal base. So if I ask you to find out the height of a pyramid, from its top point we drop a perpendicular on the base, this will become the height of that pyramid. Then we have another important term in pyramids, which is called the slant height. So if I join this apex to the center of one of the sides of the base, then this becomes the slant height. And if you join this, that means we have a right angle triangle over here now. So what we can write here, slant height square will be equal to height square plus, what is this length? This is nothing but the half of the side of base. So if I take this as the side of the base, this will be equal to side by 2 whole square. This angle is also equal to 90 degree over here, this particular angle. Basically, in all the pyramids, base of the pyramid will always be a regular polygon. If we talk about the volume of a pyramid, it is very easy. Area of base into height by 3. A is nothing but the area of base. Most of the times you will find out that there will be questions upon finding out the slant height of a pyramid, height of a pyramid, or the volume of a pyramid. Questions on surface area of a pyramid, they will be very rare. But it's not very tough to find out the surface area of a pyramid. So for surface area, we'll have to add the area of the base, which will be nothing but side square. I'm doing this for a square pyramid, so area of the base will be side square plus. Now since we are talking about the surface area, that means we'll have to find out the area of these triangular faces of the pyramid. So they will be equal to 4 times the area of one triangular face will be equal to half. Base is nothing but the side into height will be, we'll be considering the slant height in this case, so L. That is how you can find out the surface area of a pyramid. So I hope this is clear. We'll move on to the next and the last important solid figure for that, which is prism. So these are some of the images of a prism. Like we can call this a triangular prism because it has a triangular base over here. You can see that. Now how are prism and pyramids different from each other? In pyramids we saw that when we join all the vertices at a particular point, then it becomes a pyramid. So basically this is a pyramid over here. You can see that we are joining all the vertices of the base onto a point which is directly above the base over here. So this becomes the height of that pyramid. But in prism, what we do not join the vertices onto a single top point. Rather than that, the base of a prism and top part of a prism, they are same. Basically they are also regular polygons. So the first one that we have over here, this is a triangular prism. We can see that this is a pentagon over here, so this can be called a pentagonal prism. This is also a triangular prism. So how to find out the volume of a prism? Volume of a prism is nothing but area of base into height. This will be the base that I'm considering. Its area will be equal to A of this triangular base, and height will be this length. So volume of a prism is area of base into height. In the case of pentagonal prism also, you'll find out the area of base and then you'll multiply it by the height over here. So mostly questions will be based upon triangular prism. We can call a cuboid also as a prism. Now if you talk about this particular diagram over here, then this is also a prism, but in that case you will have to consider this as the base, because I told you that in case of a prism we should have the top and the base as the same polygon. So if you want to find out volume of this particular prism, how to do it? We can see that this is 90 degree. So area of base will become, let me call it base, let me call it this side as L. So area of base becomes half L into B, and then we have to take into consideration the height of prism. It will be this height. So sorry, I'll be writing this as B into H. This becomes the volume of this particular pyramid. For surface area, you simply have to add the areas of all the surfaces. So I hope the difference between a prism and pyramid is also clear. There is one more important relation between the volumes of prism and a pyramid. We saw that volume of, this is the volume of a prism, the volume of a pyramid was 1 by 3 the area of base into height. So we can see that from these two we can establish a relation which will be volume of prism is basically 3 times the volume of a pyramid. I hope this is clear. This can help you at several points. So I hope the volume, surface area, properties of all these solid and plane figures are clear to you.